Okay, so for example 6, tell whether each of the following statements is true or false and explain why. Okay, so again, with this subset, keep in mind that subset is always smaller set is a subset of a bigger set. Alright, so smaller goes into bigger. Alright, so the left-hand set should be the smallest set, the right-hand set should be the bigger set, right? And again, looking back at this picture that we have from this sheet that you have in your possession, the subsets go in bottom to top order. Get the right button here. Alright. So N's inside of W, N and W are both inside of Z, N, W, and Z are all inside of Q, N, W, Z, and Q are all inside of R, and I is inside of R. Okay, that's what we know. Alright? And again, this is the order of things of truth in these statements here. So looking at what we're looking at here, this tells me that the real numbers is inside the set of integers. That's what the statement's telling me. I'm using letters to represent these. And I hope you're okay with the abbreviations for these sets. Z is integer because I was already used for irrational. And Z is the word Zahlen, which is some German word that I think means integers. That's what the book said. I believed it. I didn't look it up. R is already used for real, so Q for rational, thinking of quotients, quotient of integers, so that's why they use Q for rational. The rest of them are pretty straightforward. R for real, I for irrational, W whole, and natural. But looking at this, is the set of real numbers smaller than the set of integers?
No.
No. Or false? Alright, so that's a false statement, okay? They wanted us to explain why, if it's true or false. So this is false, okay? All you got to do to prove a false on a subset question is to say that some number is in the first set that's not in the second set. Alright, so watch this. 1/2 is real and not an integer. Anytime you want to prove a false, just give me one example, why not? You guys are good at that. Teenagers are great at that. Right? Anytime your parents say, you never clean your room, and then, well, if you recall on December 2nd, 2013, at approximately 2:35 p.m., my room was clean and I did it. Therefore, you're wrong. You see, teenagers are great at proving false. Okay, but that's all this is. If something's false, you simply have to find a number that belongs to the first set that's not in the second set. The square root of 2 is a real number and not an integer. Fill in the blank. Pick something that's a real number that's not an integer. Any fraction will do it, any decimal will do it, any radical will do it. Pi is a real number that's not an integer. Okay? To do a truth, you simply have to state the fact of what a subset is. Every number in this set is also a member of that set. So watch this. Irrational, real.
Yeah.
And that's true, right? So this is true. Every irrational number is real. Right. That's the reason why every true statement is going to be. Every one of the things in this set is also in that set. You're just basically redefining what subset means. All right. Irrational is a subset of rational. Can anybody think of an irrational number that's not rational?
No.
Let's go back to our picture. A number that's this, that isn't that. There's a lot of them. Pick one. Pi. Okay. I think you were going with pi, right?
Yeah.
But if you go 3.14, that's actually a terminating decimals. That's rational. So we have to actually go with pi or a square root number or something like that. So this is going to be false. The square root of 2, and the square root of anything is irrational, right? It doesn't evaluate to a nice pretty number. Square root of 2 is irrational and not rational. These two sets again are disjoint. So there are no numbers in common. Okay? That'd be like the set of all dogs is a subset of all cats. All the dogs are the same as all the cats. That's not true, right? Now if we said the subset of dogs is a subset of all pets, that's not even true because we got some wild dogs. How about dogs as a subset of all animals? There we go. That works. All right. But to say irrational and rational are subsets, they're disjoint. They're not the same. It's in one or the other. So simply have to pick an irrational number that's not rational. That's pretty easy to do. Pick any one. All right. Wholes is a subset of natural. What do you think of that one? Again,
false.
False because?
0 is not.
Perfect. And that's the only number in this case, right?
Yeah.
Because they're exactly the same set except for 0. 0 is whole, but not natural. So again, for the true and false with the subsets involved, that's all you have to do. If you can find a number or numbers that don't work, state false. And all you have to do is state any one of those numbers belongs to set 1 that does not belong to set 2. If it is a subset, you should be able to say every one of these is also this. If you can't do that, you should be able to find at least one number that doesn't work.